Streamlit is probably the best way to create web apps if you are in a data related role, and that is exactly what Streamlit is used for. And so in this video, we're going to go over how you can use Streamlit to create a soccer analytics web app to show different shot maps of the 2024 Euros and allow you to filter down to different teams and players. And Streamlit is great because it is only using Python. You do not need to know any HTML, CSS, or JavaScript. And so it's going to allow us to create these web apps fast, and they're very useful web apps and they look good. And so let's go ahead and we'll jump in how to create an app using Streamlit. So to work with Streamlit, what we need to do is we actually need to create the folder and the files that we are going to use to power the web application. The first thing we need to do is we need to create a folder where we're going to place all of our code and our data that we're going to be working with. So I'm just in my documents folder. You can put this on your desktop. Just put it in a place where you are going to remember it. And then we're going to say new folder. And then I'm just going to rename it to Streamlit Euros, okay? Because we're going to be mapping all of the shots taken in the Euros. And so the next thing that you're going to need to do is you need to make sure that you have some sort of text editor or code editor, because we're going to be using Python files in this actual tutorial. And so the one that you can use, it's free, very simple, is called Visual Studio Code. I'm going to be using a version of Visual Studio Code while I do this. But basically exact same thing. So just go ahead and download that. And then after you've downloaded it, just open it up and we'll get into actually writing the code. And so the version of VS Code I'm using is called Cursor. If you want to download that get the exact same thing, you can search Cursor. Okay, so Cursor AI. And it's literally just a copy of VS Code. You can download that if you want. So I'm going to be using Cursor, but you can use Visual Studio Code. It's going to look the exact same. So now we'll go ahead, and when you've downloaded that and you've actually installed it, open it, and then we're going to open a folder. So go find where you actually put that folder. So mine was in Documents, and then I want to open this Streamlit Euros folder right here. And so now that we've opened this up, what we basically have here in our VS Code or in our Cursor is our text editor or our code editor. So this is going to allow us to actually write code and test our code and create our web app locally, okay, just on our browser, instead of pushing it straight to the internet. And then when we're done, we can have Streamlit. Streamlit actually hosts that for us, so it will be live on the internet for anybody to come see. But until we push it to the internet, nobody else can see it, and that is how we make updates and changes. And then when we're ready to push that to the internet, then we can go ahead and save our changes, and we'll use a tool called GitHub. If you're not familiar with GitHub, GitHub will allow us to store the code and host the code so that Streamlit can run the code and run the web app. So what we'll do now is we need to first do a couple of installations with pip. We need to install a couple of packages so that we can run Streamlit and create our graphs. So to do this, if you come up here to the help bar and you go to terminal and then new terminal, and then I'm going to zoom in a little bit just so it's a little bit easier to see. And so what we are going to do now is we are going to install the packages that we need. So we'll say pip install, and then we need to install Streamlit. Okay, so if you run that, and then I've already installed it, so it says I've met all the requirements. But if you haven't installed it, it will say and install everything that is going to happen. And then the next one is we need to say pip install MPL soccer. Okay, and so MPL soccer is a matplotlib wrapper that allows us to plot soccer pitches and different visualizations, and that's how we're going to plot the soccer pitch. And so now what we need to do is we need to actually create the file that's going to host our code. So we'll come over here and then just click on new file, or you can click up here, you can click new file, and we're going to call it streamlit_project.py. Okay, and so we have successfully created a Python file. And so what this is going to allow us to do is write our code, and then we can go ahead and we can make changes. We can do different things. And so this is a Python file. And with this Python file, this is where we're going to write all of the code that is going to be shown in our Streamlit web app. So to actually run our Streamlit web app, we need to go back into the terminal. So I'm just going to say clear down here. And so to actually run this, you need to make sure you are in the Streamlit Euros directory. If you know how to work with command lines, then you'll just change your directory here. But when you opened up into this Streamlit Euros, it should have defaulted to the Streamlit Euros folder. So to actually run our app locally, we're going to say Streamlit run, okay? And then the file name of where the code is. So it's Streamlit project.py. So run that, and now you can see that it's opened up a web browser and it says localhost. So this is opening it up in a browser that I use called Arc, but we're gonna copy the URL, close out of there, and we'll come back over to Chrome where we will now have our Streamlit project. So when it says localhost like that, that means it is locally on your computer. It does not mean that anybody on the internet can see it. You're the only one that can see it. So what we want to do now is we want to start editing this Python file. And so now what we can do is we can start writing the code to actually create our Streamlit app. And so the first thing we'll need to do is just import the package. We'll say import Streamlit as st, okay? And then the next thing we want to do is we can just create a title for our actual page, and we'll say st.title, and we'll say Euros 2024 shot map, okay? So now if you save it, make sure you hit save. So hit Command S if you're on Mac or Control S if you're on Windows. And then we'll come over here and it'll say source file changed, and I just click always rerun like that, okay? And so there we go. We have created the title for our actual page. And so then underneath it, we'll just say st.subheader, and then we're going to say filter to any team/player to see all of their shots taken. And then we'll give it a little exclamation mark because we're really excited about it. Okay? And so there we go. We now have a subheader and we have a title. And the important thing when we're editing this locally, okay, so when we're in localhost, is that you do not exit out of the terminal or the command prompt that you are actually running. You need it to continue running because that is how it's actually running it in a browser. Because if I cancel this, okay, so if I hit Control C like that and it kills it, and then I come over here, hit refresh, it's going to say this site can't be reached. Okay, so then if I accidentally do that, every time I have to say Streamlit run Streamlit project.py, and then it'll reopen up that browser, or I can come back over here and just hit refresh. And you just need to make sure that this local host and then the number after matches what is right here. Okay, so that is how you can run it locally. And so now what we need to do is we just need to move the data into this actual same folder right here. So I'm just going to go ahead and go copy the data. The data will be in the GitHub, okay? And so this data is just from StatsBomb. They provide all of the event data that they have from the Euros, and they just provide it for free in their API. And we're basically just going to use this as the data for our web application. To have the fastest web app in this situation, we want to have that CSV loaded into with our web app, okay? So it's going to be loaded with the Python code, and so it just has it there quickly and easily accessible. To read that in, we're going to use pandas. So this is another package that you should already have downloaded. If you don't, just open up another terminal and you can come up here and you can just say pip install pandas, okay? If you don't have pandas already installed, just make sure you have pandas installed as well. I kind of forgot about that one. So we're going to say import pandas as PD, okay? And then underneath our st.subheader, we're just going to create our data frame and we're going to read in this Euros 2024 shot map, okay? So we'll say df equals pd.read CSV, and then we'll just say Euros underscore 2024 shot map.csv like that. So now if we save that and then you come back here, nothing changed because you can't actually see. So save it, and then we're just going to say print df.head to make sure that this is being read in properly. So now if we run this and then come just refresh the page. And so if you come here, you've refreshed the page, you're probably like, okay, still nothing happened. Where's the print? But what happens is when we say print right here, it's going to print it in the terminal. And it's going to print out those results in the terminal. So print does not actually print over here. It's going to print it in the terminal. So we're doing that just to make sure that it's getting read in properly. Looks like it did. So you can just go ahead, delete that print if it read in properly. If it didn't, then for testing, you need to give it the exact file path of the CSV, okay? So now what we're going to do is we're just going to filter it down to shots. So to filter it just to the shots, we'll say df equals df, okay? And then inside brackets, df type, and then we'll say with 2 equal signs shot like that, and then we'll say dot reset index drop equals true, okay? So this is going to filter it just to our shots. And so the last thing we need to do is we actually need to split. There's a column in the data called location, and that has our X and Y values. And so what we need to do is we need to JSON loads this. So we're going to come up here. We're going to import a package called JSON. So we'll say import JSON. And we'll say df location equals df location dot apply JSON dot loads, okay? And so the reason we're doing this, if you come here, so it's kind of hard to see in this actual CSV because this is just all the data with comma separated values, but this is our location right here. So as you can see, it is a list and it is a string list. So that is why we are doing this JSON.loads, because it's going to load that into an actual list object instead of a string object. It just kind of helps us with the data type, so it makes it a lot easier on us down the road. And so now what we want to do is we want to be able to filter the data frame. And the reason why we want to do this is because when we present the actual data frame, we're going to have it default with all of the shots that were taken during the Euros. And then they're going to be able to filter by team and player. And so to actually filter down to the teams, we need to create a select box. So we'll say team equals st.selectBox. Okay, so this is going to allow us to have just a drop down of all of the teams that are available. And then we'll just say select a team. So that's kind of the title of it. And then the next option, we're just going to give it a unique list of all the teams. So we'll say df, and then instead of location, we want team, okay? And then we'll do dot sort underscore values, okay? And then dot unique, and then we'll say index equals none, like that. So if we save that, you come back here, it has select a team, and if you click on it, it has a list of all of the different teams that are available. So that is how we can create just kind of a drop-down list. We use this st.selectBox. And we're going to do the same thing for the players. But what we want to do is we want to only show the players that are available for a specific team. So for example, we don't want to show all the England players when we filter down to Spain's players. And so what we're going to do is we're going to pass in this team variable to our player filtering, and that will allow us to get a list of all the players. So what we'll do is we'll say player equals st.selectBox again, and we'll say select a player. And then here we're going to say df, and then df team, okay? And we'll say is equal to team, and then we want player, and then we'll do dot sort values, and then we want to say dot unique, like that. And then we'll say index equals none. So the reason why we say index equals none on both of these is so that it doesn't default to an actual player. So it's going to default to nothing selected. If we were to say index equals 0, it would default to the first option. So by saying index equals none, that's just going to mean that we are not going to have it default to anything. And so now what we're going to do is we're going to filter our data frame, and we're going to create a new data frame called a filter data frame, which is going to allow us to filter all the shots based on the team and the player that we have selected. So we actually are going to create a function first, okay? So to create a function in Python, we just say def, so we're defining the function. and we'll say filter data, and then in parentheses we want to give it our parameters. So we're going to pass in df, and then as well we're going to pass in team and player, okay, and then give it a colon, and then we're just going to say if team. So if we've passed in a team that is not none, we're going to say df equals df team is equal to team. So this is going to filter it down to the specific team. And then our next one will say if player. So if we've passed in a player, we'll say df equals df, and then df player is equal to player. Okay? And then we just want to return our df. So we're going to return our data back. And so now to filter our data frame, we just need to call this filter data function. So we'll say filtered df equals filter data, okay? And then we'll just say df team and player, okay? So now go ahead and save that, and nothing happens here, but if I click Albania, okay, so now the players that are available are only players that are Albanian. So it's not going to show any sort of Spanish players. It's not going to show any English players, right? But if I go ahead and I come back over to, let's do the Netherlands, now I only have Netherlands players, okay? So that's kind of how we're filtering that data. So we filtered the data properly so that it only shows players that are of a specific team. And you'll notice that I cannot choose a player because I have not selected a team. So that's kind of something we're going to limit it to. You have to select a team first, and then it will allow you to choose a player based off that team. Okay, so now that we have filtered the data frame properly, it works so that we can filter our data frame to a specific team and player. What we are going to do now is we are going to plot the actual pitch and as well the shots that were taken. So we'll go back over to our code, and the first thing we need to do is we need to import our MPL soccer package. So we'll say from MPL soccer import vertical pitch. Okay, so this is going to allow us to plot a pitch, and it'll be vertically aligned. And MPL Soccer works great because it lines up really well with our StatsBomb data. So if we come down underneath the filtered data frame, what we want to do is we want to create a pitch. So we'll say pitch equals vertical pitch, okay? And we just need to say pitch type equals StatsBomb. So that's going to create the actual StatsBomb type pitch so that it matches our data. And then we'll say half equals true, so it only plots half of a pitch. It doesn't plot the full length of a pitch. And then to actually draw this, we'll say fig ax equals pitch.draw, okay? And we'll say fig size equals, and then in parentheses, 10 and 10. And then to actually make this show up, we need to say st.pyplot, and then fig, okay? So that's going to actually make it show up in our web app. So now if we come over here, you can see we have an empty pitch right here. So to actually plot the shots, we are going to create another function, and so we'll just do it underneath the fig ax right here. So to plot the shots, our function will be called plot shots. We'll just say define plot shots, okay? And it's going to take in a data frame, so we'll say df, and then it needs to take in an axes as well, so this ax variable. And then it also needs to take in a pitch variable, okay? So pitch right here, and then colon, and then we're just going to use a for loop. So we'll say for x in df.toDict, and then we'll say orient equals records, okay? So this is how we're going to loop over all of the shots and do some operations on the shots to actually plot these how we want. And we'll say pitch.scatter. Okay, and so this is how we're actually going to plot the actual x and y values and the actual circles. It's going to plot scatter points. And our x, we're going to say x equals float. And then we're going to do x location 0. So if you remember the location, the reason why we had to turn it into a JSON object and so actually turn it into a proper list was so we could extract the first value out of that list. And then we'll say y equals, same thing, float x location, but instead of 0, we're going to do 1 because we want the second item in that list, which is the Y value. And so then just make sure you have commas after these, otherwise you'll get an error. And then we're going to say AX equals AX. And then we'll say S, so the size, we'll say S equals 1000 times X shot underscore stats bomb underscore XG, like that. So that what this is going to do is this is going to scale our dot. So we're multiplying it by a constant. So we're going to do 1000. And it's going to scale it by the value of the XG. So that way we'll get bigger circles for higher XG values, and we'll get smaller circles for low XG values, okay? So it makes it look a little bit better than just having all the dots the same size. And then we're going to say color equals green if X, and then in brackets shot outcome, okay, is equal to goal, else, and we'll do white, okay, so that it blends in with the background. And then we'll say edge colors equal black, okay, and then we're going to say alpha equals 1 if X type is equal to goal, else 0.5. Okay, so this is just going to set the transparency. So if it's a goal, it's going to be, you can see it very well. Otherwise, it's going to blend in. And then we're going to say Z order equals 2 if X type is equal to goal, else 1. Okay, so this is going to layer it. In the different layering, the higher the number of a Z order, the higher it's going to be in the layering. So we want to make sure our goals appear on top of our non-goals, rather than having it kind of just however it works. And so now we have that actual function created. We can go underneath it and we'll say plot shots, okay? We want to give it our filtered data frame, okay? And then we also want to give it our AX and then our pitch variable as well. So if you save that and we come back here, it'll run for a second on the first time you actually load it, and there we go. We have now plotted all of the different shots in the Euro of 2024, and we can confirm this works if we, we'll filter down to, let's filter to Romania, and let's filter to, I cannot pronounce his last name, but there it is, his actual goal that he scored. You can kind of check it out if you go England, and then we can do Jude Bellingham, okay? So here is one of the bicycles he scored. I don't remember which one it was. But this also does include penalties, so you can do some filtering with the data to make sure that it includes different things. You could include, if you wanted to have it select so you can choose penalties or non-penalties. So there's different things you can do with this data, but that is how we actually create the app locally. There's a lot of different cool things that Streamlit is capable of doing. If you want to add ways to, include a slider, if you want to include checkboxes, if you want to plot different things, right? But this is kind of just a basic and simple shot map and a kind of simple web app that we can create. And so now that we've created this, the next thing that we actually need to do is we need to set it up so that we can host it on Streamlit's cloud deployment. So to actually host it on Streamlit cloud and to have Streamlit kind of look at your data, what we need to do is we need to move our code into GitHub. So GitHub is kind of a file sharing, file management system, which allows us to share and store code and work with code. GitHub is very useful. This isn't going to be a GitHub course, unfortunately, because there's so many things about GitHub that you can learn. But what you need to do is you need to head over to github.com and create a profile if you don't have one, or if you do have one, then you're already set up. And then once you've created a profile, you need to create a new repository, okay? So create a new repository. I'm going to call this Streamlit Euros, okay? And it says it's available, whoopity-doo, but this needs to be a public repository, okay? It can't be private because we're making it public so that Streamlit can host this for free. And so hit create repository, Okay, so once we've actually created a repository, we are going to upload the files. If you know how to use GitHub and you know how to use Git, then you just need to make sure that you commit these into the repository. But for this, and kind of simplicity's sake, we're just going to go into upload an existing file. So go ahead and choose your files and then just navigate to wherever the Streamlit Euros are and choose both of those files to upload them, and it will upload both of those files into your GitHub repository. And it might take a second because the shot map CSV is a couple of megabytes. But once it has transferred all of that data over, you're going to just hit commit changes. Okay. So hit commit changes. It might take a second because that is some big data. But now we have this Euros 2024 shot map and the Streamlit project. So if you click into this, it shows that code. So if you're using GitHub, you can just automatically, add that code, right? And just use GitHub to add that code. And then we need to add one more file. And we're going to add a file and come up here and call it requirements.txt. So what this is going to have is it's going to have those packages that we installed. So the first one we are going to say is going to be pandas and then MPL soccer like this. So this is basically going to tell our Streamlit app what packages it needs to install so that it can run properly. So just hit commit changes like that. It'll come up with just a little bit of a message. And so now we have, if you click on code, we have our 3 files properly set up. So first we'll come over to Streamlit. Okay, so just search Streamlit, and then it's going to make you create, if you hit sign in, it'll make you create an account. Okay. I've already signed in, so I'm just going to hit continue to sign in. I usually have just been using Google. So go through the whole sign in process, create an account if you have not actually created one. And so now we just want to hit create app, okay? And say, yep, I already have it in our GitHub repo. And so we want to come and find the one we created. So Streamlit Euros, okay? The main file path is going to be Streamlit project.py. That's what we called it. And then the branch, just say main, unless you kind of know a little bit about GitHub, what you're doing. Advanced settings, you don't need to do anything here unless you want to. And then just go ahead and click deploy. It might make you, it's going to make you connect your actual, so right there, it didn't have me connect my GitHub, but when you don't have your GitHub already connected, it'll make you connect your GitHub. So now we have an actual URL for our app. So we can share this with other people. And as you can see, it runs basically normally how we have it. So if we filter down to Ivan Perisic, right, those were his couple of shots. We can do that same thing where we filtered to, let's go filter to Spain, okay, and if we were to filter to Fermin, did Fermin have a shot? Yeah, he came on and just kind of shot the ball for fun. Let's look at Nico Williams, okay, so those are his 2 goals that he scored. And then the way to see what's kind of going on with this app is if you come down here to manage app, but this is everything that's going on when you actually load up the app, okay? So it's using and it's installing stuff. It's kind of saying like, okay, spinning up everything, cloning the repository, and then it's going to install the packages, okay? So Python dependencies were installed, and it installs everything, okay? So that's why we had the requirements.txt right here, okay? So requirements.txt. And so now every change that we make, we need to make sure that we update our GitHub repository. So if, say, over here, I wanted to actually add, so let's say I wanted to change this from filter to any team player, and I just want to say filter any team, then player. And if I'm not using GitHub locally, I need to go into this GitHub, we'll go into the actual, not the CSV, we'll go into the Streamlit project.py, and you can click edit file, and then just paste over it, okay? And then commit the changes. So you need to make sure that you commit the changes every time. Otherwise, it will not update. So now if we come back to our actual URL, it'll say filter to any team, then player. So every time we commit changes to this GitHub repo, it is going to reflect those on our web app. So now we can take this web app, okay, and we can tweet it out to the world if we so wanted to, or we could share it with other people. So that is how we can create a web app with Streamlit. As you can see, it was very easy. Most of the process was just kind of creating it, getting it all set up, and then, you know, just kind of learning how to actually deploy that and host that with GitHub. And so then if you want, you can go back and you can look at it from the actual Streamlit section. So just sign back in if it wants you to sign back in. And then it kind of cleared out right there. But basically, if you come back into the Streamlit Community Cloud, you can see that I've created a couple of different ones just for, you know, testing purposes. But this is the one we created, okay? And so then you can go back into it, and it'll default to this every single time. And then if it's running something, it'll say running up here. So playing around more with Streamlit is a great way to learn how Streamlit works and kind of the cool things you can do with Streamlit. There's a lot of cool people on Twitter that are using Streamlit to create apps and create different things. So anytime you see somebody using Streamlit, go ahead and take a look at what they're using and kind of see what they're doing, how they're using Streamlit, and kind of the cool things you can do with Streamlit. And so the cool thing about Streamlit is we're able to use a lot of cool different data sources. And in this one, we use StatsBomb. So if you want to learn how to actually use the StatsBomb API to get the StatsBomb data, then go ahead and check out this video here where you'll learn how to use the StatsBomb API to extract and use all their free data that they have available.